Okay, we're going to talk about logical entailment in this video. And as you can see, I've already drawn the beginnings of a truth table. And I'm going to try to define what we mean by logical entailment through the use of a truth table. And I'm going to use the conventional symbology that's used in our textbook, as well as many other books. And that symbology can be challenging for students, so I'm going to try to tie it to a really concrete example. And this is kind of the simplest, non-trivial example that I can use. I'm also going to use this example in one of the proofs in Chapter 3. Okay, so I've set up a truth table, and if you don't know how to do this, look at the video for that. But I've begun with three logical propositions, P, Q, and R. And if I want to set up a truth table, as you already know, then the first step is to try to come up with all of the possible combination of truth values that those three logical propositions can have. So again, this is a strategy that I go through in another video, but even though it's already been taught, as you know, many students will still need help. So whenever there are three propositions, I know that there are a total of 8 possible combinations of truth assignments. And to get all of those possibilities, I always start in the left-hand column like this. And first I do 4 and 4. Then I do 2 and 2 like this. When I say 2 and 2, I mean 2 truths, 2 falses, then repeat 2 truths and 2 falses. And then I'll alternate every one. This is true, false, true, false, true, false, true, and false. Again, we've gone over this in another video. Kids, your students will need probably more opportunities to go through this, but they catch on pretty quickly. Okay. Now that I've done that, and I'm going to call these my logical propositions. So in this world, the world of this example, we have just 3 logical propositions. Also, though, what's really important is I want to define a variable that I'll use, and it's a Greek letter. Students sometimes freak out when you start using Greek letters, so I try to do it from the beginning so that they become accustomed to it. Okay, so here I'm just going to use the Greek letter phi1 and another Greek letter phi2 to represent these 2 logical sentences. This is an implication, this is another implication. Okay, finally I'm going to use a third Greek letter psi to represent this implication. So I have 3 implications, that's 3 logical sentences, and I've labeled them with Greek letters. I'm going to throw in one more level of complexity, which is not that bad, but still it does kind of freak students out. And I am going to now define these 2 sentences together to be delta, or a set of sentences. So again, over here, I'll write down delta is defined. Let me define it as a set of sentences, and that set of sentences is phi1 and phi2. So far what I've done, and it looks really kind of mathy and kind of off-putting to students, especially beginning students, is I've just defined a set of logical sentences, but I use the convention that the books use, which is that a set of sentences is represented by an uppercase Greek letter, in this case delta, and a single logical sentence is represented by a lowercase Greek letter, in this case phi. And if I have more than one of them, I'll just give them subscripts, phi1, phi2, and so forth. If I had n of them, it could be up to phi n. Okay. And I have another sentence, of course, and my other sentence I've labeled psi, and so psi is defined as this sentence, P implies R. Okay, so I've just written up some symbols, and they're kind of, freaky symbols to kids, so I'm trying to define them as carefully as I can in this context. Okay, now let's go over here. In a previous video, I talked about how to assign truth values to implications. If you need to review that, go ahead and review it. It's only like a 5 or 6 minute video. But still, when is a implication false? That's what I'm interested in. And an implication is only false when the antecedent is true, but the consequent is false. So let me write that down here. In fact, I encourage you to have students write this every time. I'm going to say an implication is false only when the antecedent is true, but the consequent is false. It's important that kids write that, because when they refer to it, if it's written, they can refer to it easily. Also, though, the act of writing it is a conceptual developmental tool. What I mean is that this helps you remember it and understand it better. Okay, so another way to say, and I'm going to put this in sort of more kid-friendly language. So if the beginning part of an implication is true, but the ending part is false, that is to say, the proposition at the beginning is true, but the proposition at the end is false, then the implication is false. And every other time it's true. So the first thing I'm going to do is find all the falses. So I'm looking for places where P is true, but Q is false. Not here, because they're both true. Here's one. P is true, but Q is false. So that means the implication is false. Another one right here. P is true, Q is false. So another false. So far the implication P implies Q is false, 2 cases. Now from here on out, P is always false. Remember, for our implication to be false, the antecedent has to be true, but that never happens here. So these are never false, they're always true. So I have now the only 2 cases where this implication is false. That means everything else is true. So I'm going to fill in my trues. True, true, true. All right. Apply the exact same rule here and see if you can do it before I do it. I'm pretty sure you could. So I'm looking for all the places where I'm going to first find the falses. All the places where Q is true but R is false. So now I'm going to look at these 2 columns. Here's one. Q is true, R is false. So I'm going to label that as false. And let's see. Here's another one right here. Q is true. Q is true, R is false. And I think those are the only 2. Yes, so everything else is true. This strategy, by the way, of finding out the place where the implication is false and filling everything else in with true, is really mechanical, but it's important that students learn how to do things mechanically at times. We're going to interpret them later, don't you worry. Okay, again, for this implication, now I'm going to say, where is this false? Anytime P is true, but R is false. True, 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 true. Oh, here's one. That's false, because notice, P is true, but R is false. And then, right now, the next one is also false, because case 4, P is true, R is false. And then that's the only 2. So I'm going to fill in trues for everything else. So I believe, if I've done it carefully, and I tried to, I believe now I've completed the truth table. Yay! So completing a truth table should be mechanical, and students need some practice doing that. You should practice, I think, with truth tables that are up to 32 cases, maybe 64. 64 would be if you want to be torturing kids, and then they start to understand why proofs are so important. And if you really want to be driving that idea home, then maybe do 128 cases if you have time, which I doubt you do because nobody ever has time. All right, now what I'm going to do is I'm going to ask myself, all right, let's see what happens, let's highlight every time phi 1 is true. It's true here, here, oh no, I made a mistake. It's not true there. It's not true there. That's not good. Fix that. Okay. But it's true here, 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 and here. I also like to come over here and put a little marker over here. True, 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 true. So phi 1 is true in 6 out of the 8 cases. Let's see now, where is phi 2 true? So phi 2 is true here, and I'll just highlight it. Here, 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 and here. Also 6 cases, but there's 6 different cases. So I'm going to highlight over here. I'm going to put a little mark here. Not there. Yes, there. 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 But not case 6, 7, and 8. So now I have marks to show when they're both true. Or excuse me, I have marks to show every case where each of them are true. I'm also going to be really interested in knowing, where are they both true? Like, where are they simultaneously true? Well, they're simultaneously true in case 1, not 2, 3, or 4, but case 5, not case 6, but case 7 and 8. So I'm going to kind of make a little note over here, and I do this quite a bit with my students. NTS stands for Note to Self. In cases, let's see, 1, 5, 7, and 8, both phi 1 and phi 2 are true. Okay, that's the cases where they're both true. Now, let's highlight all the points where, using another color, let's highlight all the points where psi is true. So it's true here, 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 and here. Again, 6 out of the 8 cases. So I'm going to mark it over here, true, true, not true these two, true, 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 true. Now, okay, notice that in every case, I'm going to now change my color. Notice that in every case where both phi 1 and phi 2 are true, in every case, and that's these cases here, in every one of those cases, if phi 1 and phi 2 are both simultaneously true, then psi is also true. So here's a point that's really hard for kids to get. But there are a couple of cases, namely case 2 and case 6, where psi is true, but phi 1 and phi 2 are not true. Okay. Let me cover those a little later. So I'm going to go back now, and I'm going to start writing down some symbols. I'm going to say that these symbols, this is this right here is a set of sentences. And this right here stands for a sentence, a logical sentence. And this symbol stands for entails. So what this sentence says here is that a set of sentences, in our case phi1 and phi2, or P implies Q and Q implies R, entails psi, or P implies R. Another way to say that is P implies Q and Q implies R entail P implies R. Okay, that sounded confusing. But let me put it in words that might be a little less confusing. In our case, every case of truth assignments and I'm going to put in parentheses here, in our case 1, 5, 7, and 8, where phi1 and phi2 are both true, then psi is also true. So every case of truth assignments that makes phi1 and phi2 true also makes psi true. So let me try to put that into more human-like language, or the kind of language that people are more likely to use. So I'm going to put it into, I don't know, student language. So when the logical sentences phi1, phi2 are true, we are guaranteed that psi is true. The word that we use for this is that phi1 and phi2 entail psi, or another way to say that is phi1 and phi2 being true guarantees you that psi is true. That's what entailment is. The confusion that you will find, let me put it down here, and this will be challenging for students. Some students get it right away, obviously, and some students don't get it right away. And by the way, I don't think that necessarily correlates to who the stronger students are. Sometimes it does, sometimes it doesn't. So we say that delta, and again, that's a set of sentences, entails psi when this is true. All right. That's the definition of logical entailment from a truth table perspective. What are students going to struggle with? Well, some students will struggle with, hold on, in case 2, psi is true, but delta is not true, so doesn't that disprove this? No, it doesn't. You'll see that that's a stronger requirement when we define another concept, logical equivalence, but we're not to that yet. So I'm going to say here, logical entailment means that if delta is true, then we're guaranteed psi is true, but we're not guaranteed if psi is true that delta is true. In other words, the implication doesn't go both ways. That's going to be challenging for students, so you're going to have to give them some examples. And I'll make another video with an example that helps kids with this. Okay, so I think that I'm done with what I want to do for this case, and you're probably going to have some questions about it. So get your questions ready. If you don't have questions, that's great. It means I did a great job, or you're just really smart. And I will talk to you later. Thank you very much.